You are welcome to today's class with Anekwe Christopher Ejike, your chemistry teacher. Today we'll be looking at the topic titled Saturated Hydrocarbon. Saturated hydrocarbon. It's expected that by the end of this particular class, you should be able to explain what saturated hydrocarbon is or what they are. Another one is that you should be able to list at least 10 first members of alkane family. First 10 members of alkane family. Number 3, you should be able to state the method of preparing alkanes. Method that is being used in preparing alkanes. Fourth one, you should be able to outline the reactions of alkanes. The reactions that are peculiar or that alkanes undergo. Then number 5, you should now be able to list the uses of alkanes by the end of this particular class. These are the objectives that we want to achieve at the end of the class. All right, let's take them one after the other. We'll be starting with saturated hydrocarbons. What are saturated hydrocarbons, or what is saturated hydrocarbon? A saturated hydrocarbon is a hydrocarbon in which all the carbon-carbon bonds are single bonds. All the bonds of carbon are single bonds. That is what we mean. When the bond that connects carbon to carbon or even carbon to hydrogen are single bond, we call it saturated hydrocarbons. Why? Because they are bonded to 4 other atoms that are not carbon itself, that every side of it is being bonded with single bond, meaning it's being saturated, it's being filled up. It's being filled up. It doesn't need any other bond in order for it to get saturated, because we know that in the electronic structure of carbon needs 4 electrons in order to attain octet. So when the 4 bonds are being bonded, are being connected with single bond, we call it saturated hydrocarbon. When it's being bonded with hydrogen, we call it saturated hydrocarbon, implying that no carbon-carbon multiple bonds exist in these organic compounds. It does not have double bonds, does not have triple bond, rather it's single bonds that are being used to fill all the bonds necessary for it to attain the octet structure. So that is what saturated hydrocarbon is. Now, the term saturated hydrocarbon is used to refer to alkanes. Whenever you hear about saturated hydrocarbon, your mind should go to alkanes, because they are the only saturated hydrocarbons we have among the, at least the homologous series. Of course, we know that we have haloalkanes, but they have been gotten from alkanes. So alkanes are the saturated hydrocarbons that your mind should ring immediately with this particular general formula, CnH2n plus 2. Saturated hydrocarbons are usually referred to represent alkanes. So the structure below, we can use it to illustrate or explain what we mean by saturated hydrocarbon using propane. When we look at this particular structure, we observe that it's 3 carbon atoms, and all the bonds connecting to carbon there, they are all single bond, one bond connecting to it. So there is no single bond on it, double bond on it, and that is what we mean by saturated hydrocarbon. It's filled up with single bonded bonds, being bonded with single bond in attachment to hydrogen. So the picture below depicts or shows what we mean by saturated hydrocarbon. All right, from that picture, you observe that a that a propane molecule is saturated with hydrogen atoms and cannot accommodate anymore in the parent chain, in the long chain, in that straight chain, it cannot contain any other atom on it unless it will replace it, but it has been bonded completely. Whereas in unsaturated hydrocarbon, it will feature at least one or two, one double bond or triple bond on it. But this saturated hydrocarbon is not like that. Everything is single bond. All right, that is for saturated hydrocarbon. The alkanes, because I said before that saturated hydrocarbon is alkane, is being used to refer to alkanes. The first 10 members of the alkane, or examples of alkane families, the members of the alkane, though we have talked about this before in our previous class, but we just need to point them out again, at least the first 10 members. The first one we have methane, second one we have ethane, third one we have propane, fourth one we have butane, fifth one we have pentane, sixth we have hexane, seventh we have heptane, eighth we have octane, 9 we have nonane, 10 we have decane, with their respective formulas being attached to that. So these are the 10 members, first 10 members of alkane family that we just need to know. And all of them are single bonds. They are bonded singly, no double bond or triple bond attached in their structure. All right, what are the things uniquely for this particular alkanes or saturated hydrocarbon? Unique things, physical properties of this alkane. Number one, we need to note that alkanes are non-polar compounds. They are not ionic compounds. They are non-polar compounds. Number two, they generally have lower melting and boiling points. Why? Because their atoms have weak van der Waals force. And so atomic bond break easily. They have lower melting point and boiling point. But as the molecule of the compound gets bigger, the force gets stronger also. So as the number of carbon atoms increases, the force of attraction there also gets stronger. Therefore, complex alkanes have a higher boiling and melting point. So as the number of carbon atoms increases, the bond holding it will also get stronger. Then number 4 is that they can exist as solids, liquid, and gases. They can exist as solids, liquid, and gases in their natural states. Because from methane, ethane, propane, butane, as you go, the first 5 or 4, they are all gases, but as we are moving down, going down, as the number of carbon atoms they are increasing, is becoming liquid. From that when you get down to hexadecane, it becomes solid. So alkanes bigger than hexadecane is 16, are all solid. But as from something like 10, 15, 10, 11, 12, 13, all of that, they are liquid. But methane, ethane, propane, butane, they are all gases. So they can exist as solid, liquid, and gases in their natural states. That is the 4th physical properties. Then the next one is that they are completely insoluble in water. Still remember that it's being made up of hydrogen and carbon. So, and they are insoluble in water due to the weak van der Waals forces that exist between their bonds. Now, lastly is that they are soluble in organic solvents. They are insoluble in water, but they are soluble in organic solvents. All right, these are the physical properties. We will be looking at their chemical properties now. Let's know their chemical properties. Okay. All right, let's look at the preparation. Okay, how can they be prepared? How can we prepare them? Before we look into how they exhibit their chemical aspect of it, their reactions chemically. Now, one of the ways is that we can prepare alkanes from unsaturated hydrocarbons. Unsaturated hydrocarbons are still alkenes and alkynes, double bonds and triple bonds. So we can prepare them alkanes from either of it, either double bonded or triple bonded. When it reacts alkane, when alkene, or if you are using alkene, which is double bond, if it reacts with hydrogen, it can it can attack the double bond and split it, break it, and it will turn to alkane. If you use also hydrogen, it can also break it. It can attack the double bond also in the presence of a catalyst. It will also attack the triple bond and break it into single bond. So unsaturated hydrocarbons, which are alkanes and alkynes, react with hydrogen in the presence of finely divided catalysts, such as maybe platinum, palladium, nickel, to form alkanes. And we can see this, we call it hydrogenation, adding of hydrogen to a double bond in order to give a single bond compound. Now, if you want to prepare alkane, propane, use propene. You use propene in the reactant, add it, it will not react with hydrogen. If you want to prepare ethane, use ethene as the reactant that will react with hydrogen, so that hydrogen will attack it. The same thing has to do with propane. If you are using alkyne, you use propene. Propene, that means one ion. You use it and it will give you propane. So either of it can be used. And when you do so, alkane will be produced. That is one of the ways we can use to prepare it. Another one very, very important and crucial is laboratory preparation. Number 2 is laboratory preparation of alkane. How do we prepare alkane in the lab? We can see a setup, Bunsen burner, retor stand, and the apparatus is being well set up, both the delivering tube and trough, and the inverted gas jar, water on it, and boiling tubes. Everything is being set up, being added. Now, the substance, in order to prepare it in the lab, we use sodium ethanoate, the powdered mixture of equal amount of sodium ethanoate and soda lime. We don't use just sodium hydroxide. We use soda lime. What is soda lime? Soda lime is a mixture of sodium hydroxide and calcium hydroxide mixed together in order to reduce the liquescent nature of sodium hydroxide. However, the active reagent here is sodium hydroxide, but because of that addition of sodium, of calcium oxide, it reduces the liquescent nature of sodium hydroxide. So soda lime is a mixture of sodium hydroxide and calcium oxide. Soda lime is not in the equation, but is in the mixture. Soda lime, the reaction between the sodium ethanoate and soda lime, when it's being heated in a hard glass test tube, the methane gas will be evolved. It will be collected over water. So when sodium salt of carboxylic acid, which is sodium ethanoate, on heating with soda lime, as I said before, soda lime is a mixture of sodium hydroxide and calcium oxide. When it's being formed, alkane containing 1 carbon atom less than the salt will be formed. What do we mean? If you use sodium ethanoate, you're going to produce ethane. If you use sodium propanoate, you are going to produce ethane. If you use sodium butanoate, you are going to produce propane. So this, you observe that the product that will be produced will be 1 carbon atom less than the reactant part of the salt. So that is it. And we call it, it can also be known as, this reaction can also be known as decarboxylation. We know that the first one is also known as dehydrogenation. It's also known as a halogenation. Halogenation or hydrogenation. Halogenation is when you use another one, but that of the hydrogen is hydrogenation. while this one is known as decarboxylation. All right, that is for second method. We can also prepare it using a metallic carbide. We can prepare a methane from what? Metallic carbide. When we are preparing methane, which is an alkane family, reaction of aluminum carbides or beryllium carbides, when it reacts with pure water, it will form methane. As the reaction, you can see the reaction now. So we can use also metallic carbides like aluminum carbide or beryllium carbide to get methane prepared. But basically, or most importantly, is the laboratory preparation of alkane, how we prepare alkane or methane in the lab. All right, that is it. Now we'll be taking the chemical properties, which are the reactions of alkane. Reactions of alkanes are just like saying chemical properties of it. Number one, unique property, unique chemical property or reactions of alkanes is this one, substitution reaction. Substitution reaction. What do we mean by that? That alkanes undergo a substitution reaction with halogen in the presence of light. What do we mean by that substitution reaction? Here we actually mean that, of course, we said that the atoms, the carbon-carbon bond of alkanes, they are filled up with single bond. What this one does is that there will be a replacement. We said it's substitution reaction with halogen. That means it could be bromine, it could be chlorine, it could be iodine, but it has to be in the presence of light. Using bromine as an example, when methane reacts with bromine, it's going to form methylbromine. Then another substance will be formed, product will be formed, hydrogen bromide. Now, this reaction is a substitution reaction because one of the hydrogen atoms from the methane is replaced by a halogen. Now, this reaction, I said before that it takes place under or in the presence of sunlight or UV light. Now, it takes processes. It takes 4 stages for it to undergo complete reaction, complete substitution. Now, let's take chlorine as an example. First one is that chlorine methane will react with chlorine and it will form chloromethane. Then hydrogen chloride will also be formed as a byproduct. That particular chloromethane will undergo another substitution by chlorine again, and this time around 2 hydrogen will be replaced by chlorine. We'll have dichloromethane. Next one, the same dichloromethane will undergo another substitution reaction by chlorine gas, and it will produce trichloromethane, meaning that 3 hydrogen atoms have been replaced by chlorine atoms. Now, the last one, that trichloromethane will be undergo another substitution to have tetrachloromethane, telling us that the 4 hydrogen atoms have been replaced by chlorine. These are the stages, 4 stages that halogenation undergoes using substitution reaction, using halogen, substitution reaction of methane with halogen. We use chlorine as an example. So either the chlorine or the bromine or the iodine will still undergo the same process. That is it, and it's very, very crucial for the reaction of alkane. So number 1 is what? Substitution reaction. All right, next one is combustion reaction. When you hear about combustion of a chemical, of a substance, it has to do with when something reacts with oxygen or when something burns in air. So when we say that methane or alkane undergoes combustion reaction, we mean that combustion of that particular methane is reaction of methane with oxygen. So combustion is a chemical reaction with oxygen in which alkane is converted into carbon dioxide and water with the release of heat energy. Now, hear this. Not only alkanes, but hydrocarbons, when they undergo complete combustion, it will produce carbon dioxide and water. Either is propane, either is butane, even unsaturated hydrocarbon. If anyone undergoes complete combustion, it will produce carbon dioxide and water. Hope it's clear that combustion of alkane or combustion of methane or ethane, any of them will give you carbon dioxide and water. You just need to balance the equation, and some amount of energy will be released. So number 2 reaction, chemical reaction or chemical property or reactions of alkane, number 2 is combustion reaction. That is what we have said so far. What can we use alkanes to do? What are the uses? We can use them as fuel, heating oil, and even as solvent. So methane, as we know, is the simplest alkane. Is used as fuel in several automobiles. We can use them as water heaters and even oven. In a highly refined form, liquid methane can also serve as rocket fuel. So you can see that we can use it as fuel, that I said before. Another one is that we can also use it as refrigerants. We can use alkane as a refrigerant in case of ethane. Ethane, we can use ethane as refrigerants, and it can also be used in the production of ethylene. Ethane can also be used in the production of ethylene, and we can also use propane as a propellant. It is being used in aerosol spray. Another one is octane. Octane is a very important component of gasoline, since it helps to prevent engine damage. So it's being needed, it's being used very much in the gasoline that we normally use. Then haloalkanes is also needed or used heavily in motor fuels, in diesel, and even in petroleum gas and the other heavy oil. So these are the uses of alkanes. So far, we have said that saturated hydrocarbon is a hydrocarbon in which all the carbon-carbon bonds are single bonds. The saturated hydrocarbons are saturated, and what it means is that all the 4 carbon atoms are being filled with another or other atoms with single bonds. Saturated hydrocarbons, we say that is used to refer to alkanes. We used to refer to saturated hydrocarbon, we used to refer alkanes to saturated hydrocarbon. So whenever you hear that on saturated hydrocarbon, your mind should go to alkanes with this particular general formula, CnH2n+2. Thank you, but before we go, we are going to take this as your assignment. WAEC exam 2001 number 4 says write an equation to represent the combustion of ethane in excess oxygen. That is WAEC 2001 number 4. Another question is methane reacts with chlorine under certain conditions to produce tetrachloromethane. State the conditions for the reaction. Name the type of reaction. Name the type of reaction that it undergoes in order to produce that tetrachloromethane. Then lastly, for that C2C, says give 2 uses of methane. I think all these things we have done them. Then lastly, that is why question 2004, number 4. Lastly, question number 3 says, give the reason why soda lime is used instead of caustic soda in the preparation of methane. I said it during the class. Number B says list 2 physical properties of methane, 2010, number 4. And that is a wonderful question altogether. Get them tried, and for further study and session, you can consult Essential Chemistry, Understanding Chemistry, New School Chemistry, compared past WAEC questions. And you can contact me through my WhatsApp line 080-655-73229, or email me at christo116@gmail.com. Thank you for being in this class. God bless you. Meet you next time.